Hello and welcome to my very first geometry nodes tutorial. I'm going to show you how I made this propeller with geometry nodes. So it's parametric, so you can change like the length and the height. I'll keep those at the basics for now. You can also change the twist along its length and some various other factors. So I'll show all the different parts and go ahead and show it in the viewer. So here's the grid, here's it translated, here's the taper, and then this one curves it, and then the next one moves and centers it to a specific position so I can do some more operations on it. This twists it along its length, so it's like that. This gives it thickness and smooths out the edges. Then I'll array it. Then I do a hub, and at the end I combine them all. So I guess let's just get into it. So first you want to start by going to the geometry nodes area, create a new geometry nodes. Excuse me. You don't need that initial group input, but we'll be adding more back later. We're going to start with a grid, and then already adding back that group input. We're going to put all the inputs of the grid into the group input, and we're going to rename them. And to do that, you go over to the side here, and then you can just click on the various names. We don't need the geometry, so we're going to name this length. We're going to name the size Y the height. And then we're going to do rename X and Y, the length and height. There we go. So next is to translate it. I guess I also want to change the length a bit so it's not square right now. So then we'll translate it, do transform geometry, and we want to rotate it 90 degrees on the x-axis to get it pointing up, and then we're also going to do some stuff to get it to translate the proper amount in the vertical direction, the z direction. Sorry, the x direction. We're gonna move it up later. So we just plug the length into multiply by half, and it moves it over. I put it in a frame to name it create grid and position. Then we're going to add a set position. So now we're going to do the blade taper. So I'm going to multiply position. Right now it's set to zeros, and we're going to be fixing that in a bit. So I'm going to go over here a bit and add another position. We want to separate the X, Y, and Z. And then we're going to grab the expedition and go into float curve. I want to get another group input and take it out of that frame. So I think I actually need a map range here, so I'll add in utilities math map range, and we want to map the length of it to from 0 to the length to from 0 to 1, and that'll put it in the range of the float curve. And then we want that to drive the z, and that'll multiply stuff. Right now it's I made a mistake because I forgot to change these other two to multiply by 1. So now you can see that along the curve at the beginning it's 0 and at the end it's 1, but if we go into the float curve node here, we can change that to be straight from 1 to 1, or we can have it be a curve along the length of it. And let's turn up the vertices so we can actually get some curvature instead of just 3 points. So you can see how I can taper towards the tip like this and give it some curvature to it. So now that we've got that, I'll clean these up, and then we can move on to the next part. We'll put that in the frame and call that blade taper. So for the next part, we're going to do the blade curve. So we want another set position. And we're going to do some math on this now. Let's move some stuff around. So we're going to start with the position from read geometry, and we're going to separate it. And we want to get the z component, and we're going to use attribute statistic to get the minimum and maximum of these. And you got to plug in the geometry to that so it can read it. Now we're going to get a float curve, sorry, a map range, and we're going to plug in the z value into the value. We're going to plug minimum into minimum and maximum into maximum. And then we want to go into a float curve after that. Now we're going to use this to offset by the y. So right now you can see it's at an angle compared to the curve, and although it's kind of backwards from what you'd expect, here I tried to flip it and it didn't quite do what I wanted it to do, so I flip it back. So just use it like that, I suppose. So that gives us a curve. And we'll put that in the frame and call it blade curve. So let's tweak it a bit so it's a little bit less extreme of an angle. Then we want to do, the next part is moving it back to the center along the y-axis. And we're also going to bump it up to be above the 0 on the z-axis. So we'll start with the position, and we're going to do separate x, y, z again. And we want the y position, And we're going to do an attribute statistic again. And this time we're just going to grab the max, because right now I know that the y position is going from 0 to the maximum. And then we'll go back into combine XYZ, and we want it to move along the y-axis in offset. I accidentally did the x-axis here, and I need to switch it to y. It's still wrong because I forgot to do minus 0.5. Sorry, minus 0.5. I think that's correct now. So now we'll call it center and move up. Oh, speaking of move up, I forgot to actually move it up. So let's drag out of the Z and do another multiply. And we're going to grab the height of that and multiply by 0.5 to get half of the height to move it up to the 0 point. Alright, let's do the next part. So I think in this part is where we do the twist. So we'll start with another set position. Lots of set positions here. And then we're going to, what's next? I just want to read the position, separated as usual. And then sorry, I'm checking my notes. We'll do a Z into the map range, and we want to get the total height of the blade height to map to 1. And we're going to do that into another thing. I guess I forgot that we're also doing the shape in this one too. So we're going to map the length to the x, and we're mapping the z to the height. And so I'm doing the x into a float curve so we can make it, we can shape it a bit. Right now I'm just going to go 0 to 0 so it does no effect. And then want to add these together. Want to multiply by the twist amount. And I think I might have made a mistake here. I think the multiply might need to go before the add in this. So the multiply would go before the add on the z component. But this works too for now. So let's plug that into offset, or sorry, position. And here's another part where I forgot to, forgot something. I know I was kind of having some technical difficulties while recording this a little bit ago. Oh, right, I forgot the rotation. And then I need another position because I'm just rotating the position of that thing. And it's still not working how I expected, so I'm looking at what I did wrong. Even now that I'm recording the audio now, I forgot what I was doing. I think the problem was that the map range on the Z was, instead of going from 0 to 1, I wanted to go from minus 0.5 to 0.5. That way, when we do change the twist value, instead of spinning around, it just goes both directions. It stays centered. There we go. Sorry about that. So we're going to call this frame blade twist and shape. And so now to explain the shape, we go over to the float curve here, and we can make it twist around, or you can make it kind of wavy. Or we can make it curve the other direction. It's good to keep it straight for now. And then you can also mess with the taper now that you have these other parts to kind of correct the warping that the twist causes. So the next part should be solidifying it, which is like an extrude. So we'll start by flipping the faces because we want to go downward. And so we'll grab extrude now. And then we're going to make a new group input to put into the offset scale. And we'll call that blade thickness. So now we're going to join these back together. Right now it's, I forgot to turn off individual extrusions. So we just want one big piece. And then we'll join those, and now we have a solid. And then we're going to add a merge by distance so that top face and the other part will connect to each other. And then we want a subdivision surface to smooth out the corners, because right now it's just a box. We don't really want a box. And right now this blade is way too thick, so we're going to change the thickness to something smaller, like 0.01 or 5. And you can make it thicker if you want. It makes it a chunky propeller. We'll just leave it at 0.05 for now. So let's clean this up, put it in a frame, and call that extrude and subdivide. So we're going to actually also add the subdivision level so we can change that if we need to. You can see how it goes down to a box if you turn it off. So the next part would be to make an array of these blades. And first we're going to start out with points, because we're going to instance them on points. So points. We're going to get another group input so we can change the number of points. I was having trouble because the thing got minimized there. So we want to change that to blade count. And then here we're going to go to an instance on points. And for the instances, we're going to use the blades themselves. And then right now, if we turn up the number of blades, it's just going to keep them in the same place, so we need to give it each one a rotation. And we're going to base their rotation on their index. So we'll grab the read index. So now I'm going to go index and multiply that by tau. So multiply tau. So with each added into the index, it'll rotate a full rotation, but we don't want it to rotate a full rotation, so we will divide it again by the blade count. So with each index, it'll be a full rotation divided by 1, then a full rotation divided by 2, and so on. It actually starts at 0. So now when you add more, they'll be evenly spaced in rotation. So we'll put that in a frame and call that array. So the next part is to make the hub. And this is, I'm just going to do this all in one chunk. So we'll start with a cone, I think. Or started with a cylinder, actually, sorry. Then we're gonna do a group input and add some new ones. We want the vertices. I want to change these to some smaller values first. We want the radius, we want the depth, and we want the vertices, so we can change those all from the input. So now we're going to do some modification to this. We'll do a transform geometry. And we want to move it up to the 0 point. So we're going to grab half of the height. Just future, it's I know that's already a mistake, so we're going to fix that in a bit. So we added some side loops. We want to do another set position, and now we're going to be able to change the shape of the side with a float curve that I'll add in a bit. So we want to go position, separate. We're going to get it based on the Z. I think we're just going to do a map range to the maximum height. It's actually the depth, but I mentioned that I made a mistake earlier. We're going to, in a bit, change that height to depth. So now when we get this into combine, I want to do that in X and Y, and we're going to put that into the position, multiply that with position, and put it into the position node, or the subposition. And right now it went flat because I accidentally left 0 in the combine XYZ, so we want that to be 1. So now you can see that from 0 to 1 it's got a radius of 0, and it goes up to 1, and then we can flip it around and we can change the shape of it with the float curve. So now we're going to join these, put it in a frame, call it hub. Now we're going to do an add join geometry and put those together. So now we have most of the propeller going. Right now I'm testing the depth, but it didn't work because instead of depth I used height. So I need to go over here and grab depth instead of height, plug it into the 2 spots where we used it. So now when we change the depth of the hub, it'll properly map to it. So next we're going to add a subdivision surface to make the cone look a little bit nicer, and we'll add some steps, but you'll notice that the bottom looks kind of weird, so we're going to put the bottom and top into a Boolean OR, and then we're going to plug that into the edge crease of the subdivide. So now you have that crease instead of it looking funky on the top and bottom. So next thing would be to do, if you want it to be a solid one piece instead of multiple geometries, you can grab a mesh Boolean, switch it to union, and I like to use manifold when I can because both of these shapes, or all of these shapes, are manifold, which means they're watertight or they don't have any holes in the mesh. So we can plug those in. I'm also going to use a switch, so we can switch between the slow Boolean or the quick just joined geometry. So we're going to plug the Boolean into true, and we're going to plug the join into false. And that way, when we look inside, you can see if it's false, you can see that the parts are separate, but when I turn it on, it's one nice clean mesh. And that's my tutorial on how to do a propeller. I hope you enjoyed. Here I'm showing some different iterations of what you can do with it. You can change the shape, you can make it bend backwards, you can come over here and change the curve to be much more rounded. It mostly affects the base if you twist it. Then you can change it to be super wide on the outside or really big in the middle. I like to keep it pretty straight. That's basically everything. Thanks for joining me, and I hope you learned something. And stay tuned for more tutorials.